Quadratic functions. We've mentioned graphing several times as we've come through, particularly the section on inequalities and the discriminant. Now we're going to look at graphing quadratic functions in a more formal way. So the most basic quadratic function is just y equals x squared. All other quadratic functions are transformations of this basic function. We can graph the basic function. So here we have a table of values with x values going from -4 to 4. And we've got some graph paper. So if you square -4, you get 16. -4 times -4, negative times a negative is a positive. When you put this into your calculator, -4 squared, you have to make sure you use brackets. Put it in like that. So we'll plot that point on the graph. -3 squared is 9. Let's put that on the graph. So x is -3, y is 9. And then we've got -2 squared is 4. And -1 all squared is 1. 0 squared is just 0. So that goes at the origin. 1 squared is 1. 2 squared is 4. So we plot 2, 4. 3 squared is 9. And 4 squared is 16. And then we draw a smooth curve through these points. If we look at a more general quadratic graph, there is some terminology that we need to introduce. So this is for a graph y equals ax squared plus bx plus c. So this particular graph here is drawn for a situation where a is positive, the coefficient of x squared is positive, and that's why the graph is this way. When a is a negative number, the graph goes this way. They're technically known as concave up and concave down, but we can refer to them colloquially as happy and sad. It's also drawn with the discriminant greater than 0, which is why we have two distinct points where the graph crosses the x-axis. Remember, if delta was equal to 0, it would just touch the axis. If delta was less than 0, it wouldn't cut the axis at all. So let's look at our terminology. The shape of a quadratic graph is a parabola. This point here is known as the vertex. It's also known as a turning point. And in this case, because it's the very bottom of the curve, it's a minimum. When you have one of these ones, the point at the top here is called a maximum. These are x-intercepts, the points where the curve crosses the x-axis. This is the y-intercept, the point where the curve crosses the y-axis. And one thing about parabolas that we know is that they're perfectly symmetric, about a line that comes down through the vertex. Not surprisingly, this is called the line of symmetry. The general quadratic equation, that's the y equals ax squared plus bx plus c, can be written in various forms. And in fact, this form here is known as general form. But we can rearrange it, y equals a, x minus b all squared plus c. And I should point out here that this b won't necessarily be the same number as the b above, and the c here won't necessarily be the same number as the c here. It's just the form it's written in. This one is known as turning point form, and we'll see how to operate with that later. And then we have this form, y equals a x minus b, x minus c. So it's a factorized form. Once again, the b here is not the same as these b's above, and the c is not necessarily the same as these c's above. And this one here is known as x-intercept form because it helps us find the x-intercepts nice and easily. We'll be looking at converting between these two forms and the information that they give us about a particular quadratic. You're going to investigate these using apps which I've embedded on the OneNote. I've got various experiments you need to perform, and think about how the different forms give you information.